Okay, for chemistry 1306, we're going over Raoults' law. From here, I have a question already written. Vapor pressure of urea solution at 78.2 grams of urea. The molecular weight is 60.06 grams per mole. In 220.5 milliliters of water at 35 degrees Celsius. Raoults' law incorporates vapor pressure. So we have our mole fraction here, and we also have our pressure. Now for this equation, we're going to need to do a mole fraction, and it's N1 over N1 plus N2 to get the mole fraction. So from here, I'm going into my N1, which is my water, is equal to 220.5 milliliters. And for water only, when you do the conversion, it will be 1 milliliter to get to grams. And then I need to convert, so I'm putting 1 mole, my conversion factor for molality, over 18.02 grams. And this is all going to equal out to 12.24 moles. Now that's my N1. I'm going to need my N2 as well, so that will be my urea. I need to find the moles in the urea. So I will start by gathering my known, which is right here, and 78.2 grams times 1 mole of 60.06 grams is equal to 1.30 moles. Now from there, I go into my actual mole fraction, so N1 over 1 plus N2. We need the total of the solution, is why we're adding them together. So I have my 12.24 mole over, my 1.30. This is my, up here, this is my N1 spot, and then this is my N2 spot. But since it's addition right here, I can place them wherever underneath in the denominator area. And so when I do this, and I actually put in my calculator, and make sure to put all the parentheses everywhere, you'll equal out to 0.9040. Now the vapor pressure for water, pure water at 35 degrees Celsius, right here, is 42.18. And when we go into this, we want to have our, basically what we're doing is we're getting the difference between the pressure of our substance and the pure pressure to figure out how much vapor pressure we have. So I'm going to go ahead and do that right now. From here, I'm going to put P1 is equal to 0. And that's my answer right here, is 9,040 times, and my pure water right there is 42.18 millimercury. There we go. And that is equal to 38.13. But you're not finished just yet. You have to get the difference between these two. So 42.18 minus our 38.13, and that is equal to 4.05 millimeter mercury. Right there. So just follow the steps. You need to gather your moles first, and then you can place it in the mole fraction, and then from there use your mole fraction to multiply by our pure water constant at 35 degrees Celsius, and then you subtract it to gain the difference.